Yes, in the last class we discussed about the molar conductance and molar conductance at infinite dilution and based upon this Kohlraas law. Now the application of the Kohlraas law. Application of the Kohlraas law. Applications of Kohlraas law. Application of Kohlraas law. It gives an idea about molar conductance at infinite dilution. Molar conductance at infinite dilution. It is represented by means of lambda naught m. Lambda naught m. Problem. Molar conductance of sodium chloride molar conductance of sodium chloride hydrochloric acid and sodium acetate at infinite dilution or 126.45 comma 426.16 and 91 per ohm square centimeter per mole. Per ohm square centimeter per mole respectively at 25 degrees Celsius. Calculate the molar conductance of acetic acid. Calculate the molar conductance of acetic acid at infinite dilution. At infinite dilution. At infinite dilution. At infinite dilution. Here they mentioned in the problem, they mentioned molar conductance value of the sodium chloride, molar conductance of the hydrochloric acid, and molar conductance of the sodium acetate. They mentioned 4, and they are asking about the molar conductance of acetic acid. Molar conductance of acetic acid. Here for 4 molecules they are given the values of the molar conductance at infinite dilution, and they are asking for acetic acid. Then we know that according to the molar conductance concept at infinite dilution, that is lambda naught of sodium chloride, lambda naught of sodium chloride is given as 126.45 per ohm square centimeter per mole. Per ohm square centimeter per mole. Per ohm square centimeter per mole. And lambda naught of hydrochloric acid is given, its value would be 426.16 per ohm square centimeter per mole. And sodium acetate, that is the lambda naught of sodium acetate, lambda naught of sodium acetate, that is the CH3COONA, that is equal to 91 per ohm, 91 per ohm square centimeter per mole. 91 per ohm square centimeter per mole. These are the data are given, and they are asking about the molar conductance of acetic acid. Molar conductance of acetic acid at infinite dilution. Molar conductance of acetic acid at infinite dilution. This is about the data they are given in the problem. They are asking for the molar conductance of acetic acid at infinite dilution. Infinite dilution. Therefore, according to the problem, we know that lambda naught of NaCl is equal to lambda naught of NaCl is equal to lambda naught of Na plus lambda naught of Cl minus, lambda naught of Cl minus, that is equal to 126.45 per ohm square centimeter per mole. Call this as an equation number 1. And lambda naught of HCl is given by lambda naught of HCl is given by lambda naught of H plus ion plus lambda naught of Cl minus ion, that is equal to 426.16. This is per ohm square centimeter per mole. Call this is an equation number 2. Equation number 2. And lambda naught of sodium acetate CH3COONA, that is equal to lambda naught of acetate ions plus lambda naught of Na plus ions, lambda naught of Na plus ions, that is equal to 91 per ohm square centimeter per mole. Call this is an equation number 3. Call this is an equation number 3. By using all the equation number 1, 2 and 3, I had to take up the molar conductance of the acetic acid. Molar conductance of the acetic acid. See here, I am expecting lambda naught of acetic acid. Lambda naught of acetic acid means CH3CO minus plus lambda naught of H plus ions, that is equal to lambda naught of acetic acid. That is equal to lambda naught of acetic acid. Lambda naught of acetic acid. How do you got here? Here Na plus will get cancelled, and here Cl minus and Cl minus are here. CH3CO minus, here H plus. Then how do you retain this CH3CO minus here and H plus here? Then either by adding equations or by subtracting equation, you should know how these values can retain. There is Na plus and Na plus, and we need only CH3CO minus and CH3CO minus. By reverting this expression, whereas lambda naught of Cl minus and lambda naught of this H plus, or by means of Na plus and Na plus get cancelled here, Na plus and Na plus and Cl minus and Cl minus and CH3CO. Total 6 ions are there. Out of 1, 2, 3, 4, 5, 6. Out of this 6 ions, you have to retain the 2 ions and reject the 4 ions, because Na plus and Na pluses are there here and Cl minus are here. Then you have to get cancel it, and you have to retain CH3CO minus and H plus, that gives rise to CH3COH. Then how to obtain? Assume that is equation number 1, 2 and 3. Can you by add all the equations? Equation number according to the Kohlraas law, then according to the Kohlraas law, according to Kohlraas law, we retain this equation. CH3CO minus lambda naught of CH3CO minus plus CH3CO, sorry, lambda naught of Na plus, lambda Na plus, that should be that side in order to get cancelled, plus H plus is there, lambda naught of H plus, lambda naught of H plus, plus lambda naught of Cl minus, then minus of, you call this is one expression, minus of lambda naught of Na plus lambda naught of Cl minus, See, this is lambda naught of Na plus, this is minus lambda naught of Na plus, they will get cancelled. Lambda naught of Cl minus here, lambda naught of Cl minus here will get cancelled. Therefore, this is the equation number 3 value, and equation number 2 value you have to add and subtract with equation number 1 value. This is nothing but your equation number 3 value plus this is equation number 2 value equation number 2 value minus equation number 1 value minus equation number 1 value. What about the equation number 3 value? That is equal to 91 per ohm square centimeter per mole plus equation number 2 value, that is 426.16 per ohm square centimeter per mole plus minus equation number 1, that is 126.45 per ohm square centimeter per mole. Then what about this value? You have to add the first two and subtract it with 3. Add first two and subtract it with 3. That seems to be 390.71. That seems to be 390.71. 390.71. That is Siemens or per ohm square centimeter and per mole. This is your answer. For board exam preparation, if suppose they ask the problem, you have to solve this problem like this method. This is the application of the Kohl's law. Application of the Kohl's law. Then out of 3 equations, usually they will give the 3 equations in your exam. Then it is your responsibility to identify, suppose this one, suppose if the acetic acid is required, then what about the component is the CH3CO, that would take up the first, and H plus, that is there, then by H plus is derived from this expression, CH3CO, that is derived from this expression. Therefore, to obtain this acetic acid molecule, you have to add these 2 equations. If suppose if for adding these 2 equations, then you have to cancel out this Na plus and Na plus and Cl minus, then you have to subtract this equation from these 2. Therefore, equation number 3 plus equation number 2 minus equation number 1, that gives this value. Is it clear? This is about the application of the Kohl's law. Usually in common entrance test or NEET exam or JEE exam, they are asking this type of one problem, and they are asking one more, that is in board exam preparation, that is in 2 marks problem. In part B they will ask. Okay. Next, problem number 2. Problem number 2. Lambda naught values for lambda naught values for lambda naught values for ammonium sulfate, comma potassium hydroxide and potassium sulfate or 266, 272.6 and 307 Siemens square centimeter per mole respectively. Calculate the molar conductance of ammonium hydroxide. Calculate the molar conductance of ammonium hydroxide at infinite dilution. At infinite dilution. Lambda naught of ammonium sulfate that is given by means of 2 times of lambda naught of ammonium ion plus 1 time of lambda naught of sulfate anion according to the Coldast's law. This value would be 266 per ohm or Siemens square centimeter per mole. And lambda naught of KOH is equal to lambda naught of K lambda naught of OH minus is equal to 272.6 Siemens square centimeter per mole. And lambda naught of K2SO4 is given by lambda naught of K2SO4 that is given by 2 times of lambda naught of K plus 1 time of lambda naught of SO4 2 minus, that's value is equal to 307 Siemens square centimeter per mole. And they are asking molar conductance of ammonium hydroxide. Usually for weak electrolytes they are asking lambda naught of ammonium hydroxide that is equal to lambda naught of ammonium ion plus lambda naught of hydroxyl ion, lambda naught of hydroxyl ion, that is equal to how much? That is equal to how much? See, lambda naught of ammonium hydroxide and lambda naught of ammonium and lambda naught of hydroxyl ion. You have to add equation number 1 and 2 and subtract with that of the equation number 3. Then it gives rise to the watt value. But you have to ensure that this half of this ammonium ion is required and half of the hydroxyl, there is a hydroxyl ion as such, and you have to cancel out these values. But coefficient is 2 here and coefficient is 2 here, and coefficient is 1 here, coefficient is 1 here, coefficient is 1 here. Then you have to reorganize that one by using your mathematics, simple addition method and simple multiplication method. Lambda naught of ammonium hydroxide is equal to half of the lambda naught of ammonium sulfate. Sorry, this ammonium sulfate. Lambda naught of ammonium sulfate plus, for KOH no problem, lambda naught of KOH minus equation third, half of the lambda naught of K2SO4, half of the lambda naught of K2SO4. Then substitute the values. Half of ammonium sulfate, that is the first equation, 266, plus second equation, keep as such, 272.6 minus half of 307, that is unit is Siemens square centimeter per second, Siemens square centimeter per mole is the unit. Then on simplification of this, it seems to be simplification of this value, it seems to be 252.1, 252.1 Siemens square meter per mole, Siemens square meter per mole. And one more problem. The resistance of a conductivity cell the resistance of a conductivity cell containing 0.001 molar KCl, 0.001 molar KCl at 298 Kelvin is 150 ohm, 1500 ohm. What is the cell constant? What is the cell constant if the conductivity of conductivity of 0.001 molar KCl is 1.46 into 10 to the power of minus 4 Siemens per centimeter. You know that cell constant is given by cell constant L divided by A is given by cell constant is equal to kappa into resistance. What is the value of the kappa? This resistance is given, that is a 1500 ohm, and conductivity is given, that is 1.46. That is 1.46 into 10 to the power of minus 4 into resistance is given as 1500. Then cell constant is given by the multiplication of these two values, that is in terms of per centimeter. That is 0.219 per centimeter. 0.219 per centimeter. Is it clear? Okay, thank you. Next I'll continue the application of the Kohl's law few problems. Thank you.